And back we are to take a look at your lesson 831 for accuracy and precision. You were given the direction to complete the missing part. This exercise, this problem paralleled what we did yesterday, except we were working with chocolate chips and cookies. Now, this table only had information in both columns at the very end, which made it kind of complicated for us to fill out. But I do know that if I have 10 cookies, I have 90 chocolate chips. And if I am going to take those 90 chocolate chips and portion them out into equal amounts into those cookies, most of us would get that 90 divided by 10 is 9/1, or 9 chips per cookie. And if 9 chips are what we get for 1 cookie, we'd write that up here. 2 cookies would give me 2 times 9, which is 18. 3 would give me 3 times 9, which is 27. 4 is 4 times 9, which is 36. And remember, each time I'm going back up here, and we talked about unit rates earlier this year, and my unit rate here is for every 1 cookie, I have 9 chocolate chips. 5 times 9 is 45. 6 times 9 would be 54. And as we move along down here, it's we have an expression that I could make from the table above is, well, that is like a number sentence that kind of tells us how we got these answers. And so this one here is my variable. So I could call it X, or I could call it C for cookies. I'm just going to put X up here because it just makes sense to me. And I could write X times 9, or even better, I could write 9X. And that's an expression. An expression does not have an equal sign. So then I can move on down here, and I've got, I'm going to take this idea up here, and I am going to multiply. And I'm going to get my calculator out here again, just so we can be efficient with my time with you here. I have 22 cookies, so I'm going to put 22 times 9, and that would give me 198 chocolate chips. And then if I have 50 cookies, so back to 0 down in the calculator, 50 cookies times 9, I would have 450 chocolate chips. Now, we can do this for any number of, or any quantity of cookies, and that's what makes using expressions a little bit more efficient than these in and out tables. Then we have some problems to solve here. And I'm going to scooch this up just a little bit. We're going to come back to this answer right here in a minute. Some of you might be wondering why I am using loose leaf paper instead of my computer printed assignments like the ones I give to you to do. That's because I'm having some printer problems right now, but that should be taken care of pretty soon. All right, so let's take a look here. This, if the number and a letter are next to each other, it's multiplication. So this is really 5 times F equals 15. Now, just like we did in our last assignment, we are going to try to get the variable by itself. The opposite of multiplying by 5 is dividing by 5. So this becomes one giant fraction that is a giant 1. And we have F equals 15 divided by 5, which is, most of us know, is 3. Over here, I have 8 times W equals 56. So again, I'm going to divide both sides by 8, and this makes a giant 1. So W equals 7 because 7 times 8 equals 56. And for this one, we're going to divide by 3. And this becomes, again, a giant 1. So we have y equals, and I'm going to say this is 9 divided by 3 is 3. 3 divided by 3 is 1, so that's 13. And then we have our last one where we kind of mix it up a little bit. 81 divided by W equals 27. Now, in order to solve this, I can do 81 divided by 27 that way. And I get 3. 3 times 27 is 81. So this would be W equals 3. And the operation I used was, well, I multiplied and divided, right? Actually, I divided, right? Division. And the reason I came up with multiplication there is because when I see these, I think to myself, what times 5 gives me 15? And that's how that 3 comes into my head pretty fast. All right. See you next time.